The James Webb Space Telescope, JWST, is acknowledged as the leading global observatory in space research. Its primary mission is to explore the mysteries surrounding both our own solar system and distant exoplanets orbiting far-off stars, as well as to study the intricate structures that compose our universe and our place within it. In a groundbreaking effort, scientists recently directed the JWST towards a star located 120 light-years from our solar system. In doing so, the powerful telescope uncovered compelling evidence suggesting the presence of carbon-based molecules in the atmosphere of a potential ocean world located far beyond Earth, astonishing the astronomical community. But how is this extraordinary discovery possible? This revelation offers an intriguing glimpse at a planet that is vastly different from anything found within our solar system, while also raising profound questions about the potential for habitable worlds elsewhere in the vast expanse of space. Join us as we delve deeper into this exoplanet discovery and explore the fascinating details it uncovers. If you're eager to stay updated on the latest discoveries regarding the universe and beyond, be sure to subscribe to our channel, like the video, share it with others, and activate the notification bell to stay informed. NASA's James Webb Space Telescope has made a groundbreaking discovery about the exoplanet K2-18b, a planet that is 8.6 times more massive than Earth. What makes this finding particularly exciting is the identification of carbon compounds, such as methane and carbon dioxide, in its atmosphere. The telescope's detection adds weight to earlier research suggesting that K2-18b might have conditions suitable for life. It appears to have a hydrogen-rich atmosphere and a surface covered by oceans. The first analysis of this exoplanet's atmospheric properties, situated within the habitable zone, was conducted using NASA's Hubble Space Telescope, which greatly enhanced our understanding of the system. It's important to note that K2-18b is located 120 light-years away from Earth, within the constellation Leo, and orbits a cool dwarf star known as K2-18. This star lies within the habitable zone of its system. Exoplanets like K2-18b, which fall between the sizes of Earth and Neptune, are a rare category in our solar system due to the absence of similar planets in our immediate neighborhood. The possibility that K2-18b might harbor a significant amount of carbon and a hydrogen-dominated atmosphere is particularly intriguing to astronomers. Many experts believe such planets may offer ideal conditions for the search for signs of life. The presence of methane and carbon dioxide, along with the absence of ammonia, strengthens the hypothesis that this exoplanet might contain an ocean beneath its hydrogen-rich atmosphere. Early research has also suggested that dimethyl sulfide, a chemical compound produced by life on Earth, might be detected in K2-18b's atmosphere. On Earth, most dimethyl sulfide is generated by marine plankton, but the evidence for this compound on K2-18b remains weak and requires further confirmation. Additional observations using the JWST telescope network should help determine if dimethyl sulfide is indeed present in significant amounts in K2-18b's atmosphere. One astronomer from the University of Cambridge explained that although K2-18b lies within the habitable zone and contains carbon compounds, this does not automatically imply that life can exist there. The planet's radius, which is 2.6 times that of Earth, suggests that its core may be surrounded by a thick, high-pressure mantle of ice, similar to Neptune. Furthermore, it has a thinner hydrogen-rich atmosphere, and its surface is ocean-covered. While liquid water oceans are anticipated on this exoplanet, there remains the possibility that these oceans may be too rigid or insufficient to support life. Nevertheless, researchers have successfully obtained the most detailed spectrum of a habitable subneptune planet to date, enabling them to identify the molecules present in its atmosphere. A member of the Cardiff University team explained that this challenge was overcome by analyzing light from K2-18b's host star as it passed through the planet's atmosphere. K2-18b is classified as a transiting exoplanet, meaning its brightness dims when it crosses in front of its host star. This is how NASA's K2 mission first identified the exoplanet. During these transits, a portion of sunlight passes through the exoplanet's atmosphere before reaching space. Telescopes like the JWST can detect signals left behind as sunlight filters through an exoplanet's atmosphere, providing valuable data to identify the gases present. The research team plans to conduct further investigations using the JWST's mid-infrared spectrometer to confirm their findings and gather more data about K2-18b's climatic conditions. Their ultimate goal is to search for signs of life on habitable exoplanets, a breakthrough that could radically change our understanding of the universe. Furthermore, the JWST has made other extraordinary discoveries. Astronomers using the telescope have detected complex organic molecules resembling smog or smoke in a distant galaxy. This discovery marks the earliest known detection of such molecules in the universe. Personally, I find this both awe-inspiring and unsettling, as these findings from the farthest reaches of the cosmos are reshaping the very foundations of our cosmology. The importance of this discovery lies in the fact that these molecules, known as aromatic hydrocarbons, were found in a galaxy that formed when the universe was only about 10% of its current age. These carbon-based molecules, which are found in petroleum and coal deposits on Earth, as well as in atmospheric pollution like smog, are large and complex, composed of dozens or even hundreds of atoms. What makes this discovery so remarkable is that such large and complex molecules were formed so quickly after the Big Bang, defying expectations based on our existing cosmological models. To put this in perspective, the light detected from this early galaxy began its journey less than 1.5 billion years after the Big Bang, while the universe is currently about 13.8 billion years old. This means we are witnessing some of the first steps in the universe's evolution. What is most impressive is that the detection of these complex organic molecules was made possible by the Webb Telescope, which will continue to allow us to make similar observations for nearly a billion more years. If we could observe even further back in time, could we find even more of these molecules, perhaps closer to the Big Bang itself? This raises profound questions about our science and understanding of cosmology. Until now, previous attempts to detect complex organic molecules in ancient galaxies could only confirm their presence, but with Webb's higher resolution, we can now examine the fine details of where these molecules are located. Additionally, the uneven distribution of these molecules in the early galaxy SP4 to 1847 remains an unsolved mystery. What is truly impressive is that this galaxy was already as massive as our own, with stars that had generated as much carbon and oxygen as those in the Milky Way, despite being only 1/10 the age of our galaxy. As humanity ventures deeper into the unknown, armed with knowledge and insight, we are humbled by the vastness and complexity of the cosmos. With each scientific breakthrough, we move closer to unraveling the mysteries hidden in the stars. As our cosmic exploration network continues its work, it's only a matter of time before the universe reveals more of its secrets, shining even more brightly. Let us know your thoughts in the comments section. If you enjoyed the video, don't forget to subscribe and turn on the notification bell. As we advance in our understanding of the universe, the James Webb Space Telescope continues to provide us with groundbreaking insights. Its observations are reshaping our perspective on exoplanets and other celestial bodies, pushing the boundaries of what we know about the cosmos. This extraordinary telescope allows us to peer deeper into space than ever before, uncovering mysteries that have long eluded scientists. The discovery of complex organic molecules in distant galaxies is just one example of how the JWST is transforming our knowledge of the universe's early stages and its ongoing evolution. One of the most fascinating aspects of these findings is the possibility that life, or at least the building blocks of life, may exist in places we once thought inhospitable. The detection of carbon-based compounds in the atmospheres of exoplanets like K2-18b opens new avenues for studying potential biosignatures on planets that may resemble Earth in some ways. These compounds, including methane and carbon dioxide, are often linked to biological processes here on Earth. However, their presence in distant worlds does not guarantee that life is present. Instead, it prompts further investigation into the conditions that could support life elsewhere in the universe. NASA's future plans for exoplanet research focus on this potential. The Webb Telescope's ability to analyze the atmospheres of exoplanets with such precision is a significant leap forward. It allows scientists to detect not just the presence of basic elements but also the complex molecules that might indicate the existence of life. This level of detail is crucial for understanding the potential habitability of distant worlds. As our understanding grows, so too does our ability to detect subtle signs of life, whether in the form of atmospheric gases, organic molecules, or other markers that could point to biological activity. In addition to its work on exoplanets, the JWST is providing valuable insights into the formation and evolution of galaxies. By observing distant galaxies, astronomers can trace the history of star formation, the distribution of elements, and the processes that drive the growth of galaxies. These observations are crucial for understanding the origins of our own galaxy, the Milky Way, and how it has evolved over time. The discovery of aromatic hydrocarbons in a galaxy that formed only a fraction of the time ago compared to our own is a testament to how much we are learning about the early universe. As we continue to explore the cosmos, each new discovery brings us closer to answering some of the most profound questions in science. Are we alone in the universe? What conditions are necessary for life to thrive? How did the universe evolve? And what lies ahead in its future? The James Webb Space Telescope is providing the tools necessary to address these questions, offering a window into the farthest reaches of space and time. In the coming years, we can expect even more groundbreaking discoveries from the JWST. Its ability to study the early universe, exoplanets, and the fundamental processes that shape the cosmos will undoubtedly lead to new insights that challenge our current understanding. The potential for discovering new planets, studying their atmospheres, and uncovering evidence of life beyond Earth is more promising than ever. With each observation, we are reminded of how much there is still to learn about the universe. The Webb Telescope, with its unparalleled capabilities, is leading the way in our quest for knowledge. It is not just a tool for astronomers. It is a symbol of humanity's curiosity and drive to understand the cosmos. As we look to the future, we can be certain that the discoveries made by the JWST will continue to inspire and transform our understanding of the universe, helping us answer questions that have fascinated humans for centuries. As the telescope continues to scan the skies, we can only imagine the incredible breakthroughs yet to come. Whether it's the detection of new exoplanets, the exploration of distant galaxies, or the discovery of life in places we never thought possible, the James Webb Space Telescope is at the forefront of space exploration. Its mission is one of discovery, one that will shape the future of astronomy and our understanding of the universe for generations to come.